Let's talk now about what React is. React is a way of creating components for writing HTML applications, and JavaScript applications. Prior to React, what normally happened was you would have the DOM, which is some model with all this stuff in it. It's this whole tree, and every element for the HTML exists in the DOM. And then you would have different pieces of JavaScript that would read and write to elements of the DOM. That led to a bit of chaos. If something in the DOM changed, like let's say the user typed something, then that might give a notification to various pieces of JavaScript. The JavaScript in turn would then go and make changes to the DOM and so on. So this unstructured changes to the DOM turned out to be really hard to reason about and to code with. Instead, in React, we do something simpler. Basically, your JavaScript never, 99 and 44 100ths of the time, doesn't touch the DOM directly. Instead, your JavaScript emits a tree of components. And these components are then converted into the DOM by React. The components can be either standard HTML elements, or they can be new components that you have written. For instance, this one might be a div, and this one might be something you wrote called my component. What's my component? Well, my component turns out to just be a function that gets some properties, and it would return whatever is below it. That is, it's responsible for this whole subtree, and this subtree can consist of other components. So it's very easy to delegate and abstract your entire HTML page. So you create these components, you write these small components that return either other components or return HTML elements, or you construct those into a hierarchy and return those. The other important thing is we have properties. So properties allow a way for a parent to communicate information to a child. So the parent can configure the child. And then what React does is construct the DOM from these components. It does it in a smart way. Part of what made this kind of revolutionary was they don't just rebuild the entire DOM, because this component hierarchy can be very large. You could have thousands or tens of thousands of elements in this tree. And so reconstructing the DOM on every potential change would be a nightmare. Instead, what this conversion does to the DOM is it actually looks at the old state, looks at the new state, and then calculates minimal changes to the DOM. So if the only difference between the old state and the new state is there one single new element, it'll go ahead and add that new element to the DOM. If the difference between these two is that there's an element in the DOM that's been removed, it'll remove the DOM element. If the difference is that one of these elements in the DOM, let's say a paragraph, has the words changed, it'll go change those words in that DOM element. And it can also do, of course, larger changes as well. So if there's a whole swath of the subtree that's gone, or if this one's changed and this part of the subtree is gone and this one's new, it'll go ahead and again, calculate those minimal changes necessary. And the advantage of this is then this can conceptually allow this recomputation on any change. If the user types, let's say a character, we can just handle that, re-render the component, and then React will then figure out what changes need to be made to the DOM for that. And it has enough optimizations that that is fast enough to actually work. So one optimization might be, for instance, if the properties in your component haven't changed, your component doesn't need to re-render. Goal for components is that they be stateless. That is, pure functions. If you pass in the same props, you'll get the same result. That's not always possible. You might have a timer component that's showing the current time, and clearly it can't render the same at 12 p.m. as it does at 1 p.m. because the time has to change. So that would not be a pure function. But in general, if you have pure functions, those are easier to test in isolation. They're easier to reason about, and they're also easier to optimize with. So the basic fundamentals of React include the fact that we're creating these components. And let me show you what HTML looks like when you are using these components. It's really relatively straightforward in that you can add in your JavaScript code HTML snippet. You can add, for instance, a div along with a slash div. So this might be something you return somewhere. And then within those, you can have other elements, paragraph elements, break elements, other sorts of things. But the other thing you can have is anything that starts in a capital is one of your own components. So these are JavaScript components as the built-in HTML components. So lowercase are HTML, uppercase are React components. Often what you'll have is a my component. You might have some properties like data equals 1, 2, 3. And then this is part of the information that gets passed down into the properties here. We could have my component. We could also have, let's say, an image. And we could have a paragraph. All intermingled here so that we are mixing both, again, HTML elements and React components. The basic things about React are, one, that we can have these components that we use as if they are part of HTML. So once we've written it, we can just use it as another element in our HTML. And then a second is we are always, conceptually, we're rendering all of our page every time anything of interest happens. So we have some possibly global state information somewhere else that gets changed in response to user input or network effects or anything else. And then we take that state and we generate our hierarchy of components. And React will then go update the DOM. Those are the two main features that really make React what it is.